let's show more relationship between sets using Venn diagram. But what we'll do here is we'll start from where we started in the last video, so that anybody that stumbles on this video can just grasp everything, can grasp the concept. We'll start from the first part. Let's start from the first part. Let's say we have a universal set like this. Let's say we have a universal set like this, something like this. Let's say we have a universal set like this. And then universal sets are always represented in rectangles using Venn diagrams. So, and we have inside the universal set we have subset A, and we also have subset B like this, subset B. Now in the universal set we have elements 1. Now in the subset A we have element 2, 3, and for subset B we have element 4. Okay, so these are the elements of the universal set 1, 2, 3, 4. These are the elements of the subset A 2 and 3, and these are the elements of the subset B 3 and 4. Let's say we have something like this. Now use this concept here to show the relationship between any two sets using Venn diagram. All you need to show the relationship between any two sets using Venn diagram is to first just do something like this first. Okay, showing that the subsets A and B have an intersection at this point 3. Okay, so let's say the universal set definitely will be, the universal set here definitely will be 1, 2, 3, 4. It will consist of elements 1, 2, 3, 4. 1, 2, 3, 4. These are all the elements of the universal set. All the elements inside the universal set. Now, all the elements in the subset A, all the elements in the subset A are 2 and 3. 2 and 3. While the elements in subset B, the elements in subset B are 3 and 4 respectively. 3 and 4 respectively. Now if you check here, we can find the complement of A and B. You know the complement of any set refers to the elements in the universal set that are not in that particular set. So let's find the complement of set A. The complement of set A. The complement of set A will be elements in the universal set that are not in A. Now if you check here, what are the elements in universal sets that are not in A? We have 1 and 4. 1 and 4 are in the universal set, but they are not in this set A. That's the complement. We represent the complement like this: A prime, something like this. This complement of the set A. So this is 1 and 4. 1 and 4. Now for the subset B, we'll find the complement of subset B, which is this. So the complement will be elements in the universal set that are not in B, which are 1 and 2. You know 1 and 2 are here, but they are not in set B. So you write it here: 1 and 2. 1 and 2. Now we are done. Now let's start doing this. Let's say we have a set, something like this: A union, then B, all in complements, all complements like this. A union B, all complements like this. Okay, so now let's say we have to draw the Venn diagram of this type of set. The first thing we need to do here is to find what A union B complement means. And to do this, the first thing we need to do here is to first find A union B complement. Don't just go ahead to find A union B complement like that using this sets here. Find A union B, the one inside the bracket. First find it. First find what is inside the bracket. We have A union B, A union B, A union B. Find what A union B is. So find what A union B is. This is A and this is B. What's the union between A and B? The union of A and B represents all the elements in both the set A and set B without repeating anything. So we'll just pick 2, 3, and 4. 2, 3, and 4. 2, 3, and 4. That's the union between set A and B. Okay. Now the next thing is to find the complement of the set. You know, after finding A union B, we need to find the complement. So to find the complement, what we'll do is, what are the elements in the universal set that are not in this set? That's the complement of A union B. Elements in the universal set that are not in this set. That's the complement. That's this complement here. So let's do that together. Let's look. What are the elements here that are not here? We have 2, 3, 4 here. We have 2, 3, 4 here. But this is 1 here, and 1 is not here. So 1 is the element in the universal set that is not in the set A union B. So it means our answer is going to be 1. 1. 1, 1. So let's draw the Venn diagram. We can easily draw the Venn diagram with this information here. So I just come here, I just come here, I just come here, draw my Venn diagram, draw my beautiful Venn diagram. The first thing is to write the subsets, draw the subsets of A inside. Like in this case, just do something like this again, replicate this diagram again, and you have something like this, the subset B. Then write all the elements again, 1, 2, 3, 4. Now ask yourself, which portion in this diagram represents the element 1? Which portion? If you check here, we have just 1 outside. 1 is outside the subset A and B. It means this portion outside, all this portion outside, all this portion outside, all this portion outside represents that set A union B complement. A union B complement. All this portion outside represents A union B complement. All this portion. Because we have 1 outside. All this portion represents A union B complement. So this is how to draw the Venn diagram for this type of set without racking your brain. Let's try another one. Let's say we have something like this. A prime minus B prime minus B prime. Now before we do this, I'd like us to know here that A union B prime is still the same thing as if you have A union B prime, this A union B prime is still the same thing as A prime intersect B prime. These two are the same thing. I like us to know that these two are the same thing. To prove that, let's just see. Here we have this set represents 1. This set represents 1. What about this set? Now let's look for A prime intersect B prime. This is A prime here. This is B prime. So let's find the intersection between these two sets. That's what is the common element between A prime and B prime. Now if you check here, we have 1 and we have 1. So it means the common element is 1. So the set will be 1 here. So you see it's the same thing. Okay. So these two is noteworthy to keep this in mind that these two are the same thing. So let's go back to our question here. This is A prime minus B prime. A prime minus B prime. The first thing we need to do here is find what A prime minus B prime represents. What A prime minus B prime represent here. This is A prime. This is B prime. You know, A prime minus B prime is just like 5 minus 2. Okay, you have 1, 2, 3, 4, 5, and you have 2. You have 2 here. It means remove 2 from 5. By the time we remove 2 from 5, we are left with 3. It means the final answer is 3. We are left with 3. That's what we'll do there again. A prime minus B prime means remove B from A. So this is B here. Remove B from A. This is B. So we'll just remove whatever we have here from A. This is 1 here. This is 1 here. If I remove 1 from this, this 1 here will cancel this 1 here. We'll be left with 4 in A prime. Okay. A prime will be left with 4. Just forget about 2. Since there's no 2 in A prime, just forget about it. We'll concern ourselves with 1 because there's 1 in A prime. This 1 here, we cancel this 1 here. And in A prime, we are left with 4. Like in 5 minus 2, we were left with 3. Okay? We are left with 4 here. It means the final answer here will be 4. Will be 4 here. Okay? So we can draw the Venn diagram of this. We can draw the Venn diagram. Just replicate this diagram here. Replicate the diagram here. But that's something like this, something like this. So draw the subset. For the subset, you have A like this. This is this doesn't look good. It looks zigzag. So this is A. The other one is going to be B. The other one will be B. Okay. This is B. Then just put all the elements. 1, 2, 3, 4. 1, 2, 3, 4. Now which portion has 4 here? The portion that has 4 here is this portion here. This portion here. This one doesn't look cool. This portion. Yes, this portion. So this portion represents A prime minus B complement. That this portion, all this portion represents A prime minus B complement. That's this portion here. This portion. Now let's try another one. This is just how you can show the relationship between any two sets. Let's try another one. Let's say we have something like this. With this skill, you can do anything. You can do anything with this skill. And this is minus B. This is minus B. This is minus B. Now let's draw the Venn diagram for this one also. Let's draw the Venn diagram. The first thing is to find what A prime minus B represents. So we come here. What is A prime minus B? This is A prime. This is A prime. Then this is B here. So let's remove B from A complement. That's what this means. The difference between A prime and B here. So we just say here 4 here. We cancel this 4 here. And we'll be left with 1 here. We'll be left with 1. Ignore this 3. Since there's no 3 here, just ignore it. 4 we cancel this 4 here. And we'll be left with 1 here. It means this set will be 1. It consists of element 1. So this set will definitely be something like this, something like this, something like this, something like this. Let's draw this. Just replicate this again. We'll have something like this. This is A. Then for the subset B, this is subset B. This is subset B. Then just put the elements. You have 1 2 3 4. 1 2 3 4. Now this is element 1 here. So it means this set A minus B prime represents all the portion that has 1. Now the portion that has 1 is this portion outside the subset A and B. So we'll just shade this portion. We'll just do this to this portion. Just shade this portion. Now this is the portion we are looking for. This is the portion. This is the portion we are looking for. And we got it. We got it. We got it. We got it. So this is the portion. Now you notice something here, that A union B prime or A prime intersect B prime, that's A complement intersect B complement, is still the same thing as A complement minus B. You see, using Venn diagram, you can visualize so many things. So here we can just say A union B, A union B, A union B prime is equal to A intersect B prime, which is still the same thing as A prime minus B. So these are all the same. They are all the same thing. So this is the beauty of the Venn diagram. You appreciate visualization when you use a Venn diagram compared to just using curly brackets like this. And this was John Venn's idea, and that's why I talk so much about John Venn. I think he liked visualization. He loved visualization too. So